Good afternoon. My name is Simon Dickerson. I work at Imperva, and my presentation is to introduce you to a application security solution called RASP, Runtime Application Self-Protection, and the benefits that you can get from implementing such a solution. But first of all, what is RASP? This is a Gartner link, and RASP is a server-based application security product that looks at all of the application payloads that are coming through from the application and want to look at and execute on the database or on the actual server. So it very much differs from the edge protections such as the web application firewalls. It very much sits where the application is and understands the context of the application itself. So why would you want to look at RASP? The reason behind this is most companies and organizations are always looking at what they can do to secure their applications, protect them from breaches. There are many surveys out there. This one, the two primary use cases here are that companies wish to discover and patch vulnerabilities in their applications, in their systems, and also they want to prevent zero-day vulnerabilities from happening, such as things that we have seen with Struts several years ago, WebLogic last year, and so on. Now, these two cases are in people's minds more than any other, as you can see from this slide. And they are two use cases that RASP, the Runtime Application Self-Protection, is absolutely suited for and can help you with it. Now, the problem today is a common one for anybody who has an application open to the internet. If that is the case, then bad actors will find those applications and they will try and get an entry point to steal information or money. And they will use very sophisticated techniques to discover flaws in your applications, in your code, in your network once they have got into the application itself. Now, most application code has some vulnerabilities, but this is not just the case with your code. And you will find a lot of these vulnerabilities through testing. But most web-based applications use third-party code as well, whether that is simply sitting on top of the application server, that won't be yours, whether it is incorporating open source software and so on. And you know, this statistic here from Veracode, 83% of websites have third-party code. And you do not know what is in that code or whether that is actually vulnerable. And those vulnerabilities will be our zero-day attacks that can come. Now, despite the best efforts of secure software development with all of the code scanning tools, vulnerability management programs, software development life cycles, critical applications remain vulnerable for way too long. And applications will go out onto the internet with known vulnerabilities. And part of that comes from several software challenges that we see all organizations facing. All of our customers acknowledge that these 6 issues are real challenges for them. And vulnerabilities are out there because there is pressure from the business to release these applications. These applications make the business money when people use them. And so when they change, they want those changes, those updates out into production as fast as possible. Now, all of these applications you will test. You will go through code testing and dynamic testing, but these are very, very time consuming, leading to those delays in putting applications into production. They are also very expensive, and it may be the case that you run many of these before your application gets out into production. And with agile development these days, those changes happen all of the time. One of the issues that comes out of doing any testing, of course, is you get a big long list of where your code is vulnerable. And how do you prioritize which ones those are? Sometimes it can be hard in the big long list to actually find the vulnerabilities that matter most. And of course, you know, those people developing applications, they are not security experts. They may have some training. And as I've mentioned, you know, all of your applications, or most applications, will have third-party code. They may be legacy applications now that you will not change, you don't want to change. And part of the issue then is you've done all of this testing, you know there are vulnerabilities, you've got your application into production. How do you know if it's being attacked? If an attack gets through your edge mechanisms, your web application firewalls, through to the application and the database, how do you know what is happening at that application? Can you see any of the attacks that are actually going on? And the answer to that is normally no. And so, you know, RASP here, I am putting forward RASP as a solution to those challenges, to securing your applications and making sure those applications are secure by default. Now, I'd like to go through a couple of case studies that we have, some quotes from our customers, and then come on more to introduce what RASP is and how it is actually implemented. So common to all of our customers here, some of the quotes are, you know, RASP as an option gives us more time to clean up our backlog of vulnerabilities. Those vulnerabilities we know about from our dynamic testing, our interactive testing, those that may not have been fixed, but the application has been released. Companies have edge protections in place, the web application firewalls, you may have some bot protection, that type of thing. But those firewalls typically require rules, they require attack signatures to be defined. And with the applications that change very, very frequently, the firewalls become a bottleneck. They can't keep up with the signatures. You have to identify, you have to learn, and you have to create those rules. And so, you know, one of the things our customers say is that the firewalls cannot keep up. Now, 1 week to maybe fix the firewall, maybe 1 week too long, as your applications will be continually probed. If you're going to implement a solution, certainly where application developers, the operations teams, etc., are concerned, if this has a big impact on those teams, it will not get done. You know, there will be a lot of people involved from application security and so forth. So anything that you do needs a small team of people to do it, and you must be able to do it quickly. And if it takes time, if it takes a lot of administration, if it takes a lot of maintenance, it is not going to happen. And RASP is not that. RASP is very straightforward to deploy and very, very low maintenance. Now, one of our major customers in the United States of America, a top retailer, purchased RASP several years ago now for their Black Friday and their shopping websites. And in the first 4 hours, as you can read here, they had 10,000 attacks get through their edge protections, and they were all blocked by our Imperva RASP solution. One of the things that they noticed, one thing that is very important to our customers, is that where the users interact with their websites, they do not notice any performance problems. And this has been verified by all of our customers. And as you can see here, this retailer is very, very pleased with the performance that they have. One of the top telecommunication companies in the world, they have hundreds of applications, many legacy applications written with old versions of Java, Java 6, 7, 8. But not just that, they have many instances of each application, different versions that have gone on through different development, many of which now they just do not want to change because the original developers have left and so forth. Now, when we were in conversations with them, they were hit by the Struts zero-day vulnerability from a couple of years ago, and they did some patching. But another issue came around and they had to do some upgrades. And as you can imagine, 500 critical applications take a long time to upgrade. They use many different application servers, many different databases. And now what they have is RASP is now protecting those applications. And because RASP understands the context of the application and sits up the server, and it is at the application server level, it can protect against third-party code, zero-day vulnerabilities. A financial organization that we have as my last example, they use WebLogic, which was found to have a vulnerability last year. They had already patched it several times, and that cost involved in patching was greater than 1.2 million US dollars. With the T3 protocol vulnerability, as it is called, that would have allowed remote command execution had an attack taken place on that. But this then required not just patching, but a full upgrade of WebLogic on each of their servers. Now, in order to gain time and to protect applications while things were being upgraded, which does take that cost and that time and testing, and an upgrade may actually break the application, of course, they now use Imperva RASP to protect against this vulnerability. So, you know, what is RASP and why, in addition to those quotes that I've just given you, would you want RASP? Well, RASP, as I mentioned, is a server-side technology. Imperva RASP is a simple plugin to your application server, and how it is controlled is through a configuration file. We recognize each application is different. Each application may have server-based items that it needs to access. Maybe it's accessing a different file server, for example. And so the RASP configuration file is about tuning the way that it works in order that your application functions correctly on the server as it would like. Once you have installed the plugins, you have the configuration file, it will just run. And it will look and try and detect any exploits that are coming through to the application. And if it finds any, it will block them according to your configuration. And it will also write out to a JSON format log file, which can then be forwarded onto the SIM. For example, as you can see on the right-hand side there, Splunk or Elasticsearch and so on. Now, RASP will only write when it detects an exploit. So this is not a log file or a report that is going to fill up absolutely massively in the same way that some of your security scanning tools will do so. And so what this report will give you is a very, very detailed insight into any attacks, and you'll be easily able to see what they are. And you'll be able to determine where in the code they are actually being exploited. And also, in the case of SQL injection, for example, what the actual SQL query was that may have gone to the database. So it is a straightforward deployment onto the application server, controlled by a configuration file, giving you a very, very detailed look at what attacks are happening on the application. But that said, you know, what effect does it have on the actual application itself? I have mentioned the performance impact is very, very low, not even noticeable by the users. But just to give you an example of what would happen in an application, we have a very, very simple, straightforward, vulnerable Java application that you can see here that does stock ticker prices. If I type in the ticker price Goog, G-O-O-G, you can see there I will get the results for Google and their stock price. At the bottom there, because this is a demonstration application, I've highlighted with that red arrow the result that came from the database, and so the key was Goog. Now, if we put in a bad payload, a SQL injection attack, as the one you can see here, the SQL injection is OR to TS vector and so forth. what the application does without any protection is that SQL injection is essentially a tautology, and it has resulted in the entire database table being returned to the application. And you can see there at the bottom, AAPL, Goog, and so forth for the rest of them. And that is without protection. Now, with the Imperva RASP protection that we can put into place, the same payload now, RASP is actually going to return an error message back to the application. So there is a violation exception, and this error message will change according to the exploit that RASP is detecting. So RASP is returning an error message to the application. In this case, we have set it, because it is a demonstration application, to display the error message. But of course, the application would handle that nicely and may say, I am sorry, we do not know, the answer to that question or whatever. So RASP here is working at runtime, it's working on the server, and it is looking at every payload that is coming through the application to see whether or not there is an exploit. And it will either block or do other things according to your configuration. So the benefits of Imperva RASP, they are many, but fundamentally here, it is, as soon as it is implemented, it is protecting you. There are no attack signatures needed. There are no rules. There is no learning required of a RASP solution. Because it is at the application server level, it is protecting your application third-party code, zero-day vulnerability protection. When you are in the QA environment doing all of your tests for the dynamic testing, you will see a massively reduced vulnerability score. That then allows you to prioritize those vulnerabilities and the fixing of those by the application development team. In runtime, in production, you get full visibility into whatever attacks are taking place within the application. You will know the line number of the code where the attack has taken place. You will be able to see details of, the SQL queries I've mentioned, and you will have a full stack trace so that you can trace any third-party code, any server-based attacks, exactly what is happening as part of that attack. This ultimately means, because you have this protection of 0 day, there's no learning, you've got less vulnerabilities, you can push your applications very much faster into production, and your organization can then benefit from the application, from any changes that you had in the application much faster. This also makes for much happier developers because they like to see their applications being used. It also gives them more time to fix bugs. Now, Imperva RASP, why? Well, as I've mentioned, there's no signatures. It doesn't need a day-to-day maintenance. It doesn't need the firewall rules set up, for example. But one key thing is it also doesn't need any external connectivity to any other server. It doesn't need to contact Imperva for rule creation or log files or anything like that. It is completely self-contained. It doesn't require any additional databases. It doesn't require a service account. It uses very, very little CPU and RAM and so forth. You install the application server plugin and you go, it's done. That plugin is installed very, very straightforward into things like the Tomcat, the WebSphere, the WebLogic, and so forth, or Microsoft's .NET Core environments and Node.js. And it is fundamentally, as a summary, it is detecting and preventing attacks in real time on the server itself. And, any security solution is not going to be used in isolation. You will have those edge protections that I've spoken about. You will have the monitoring tools at the other end. You've got database activity monitoring, etc. And so Imperva RASP it complements, it adds to all of those other solutions, providing you a complete security solution from end to end with your firewall all the way through to your database. So in summary then, what do all companies want to do? They want to push their revenue-based applications out to market faster and more securely. This not only makes the organization money, but it keeps the whole development teams much, much happier. So they can do this by implementing a RASP solution. And that RASP is securing those applications by default, giving your applications the ability to defend themselves. You are embedding security into the application and it's activated at runtime. Now, since it is securing them by default, it can be protecting legacy-based applications, third-party applications, any applications containing third-party libraries, and it's reducing the risk and freeing up the team from doing some expensive patching of any of the vulnerable code. Now, since RASP is, preventing these applications with vulnerabilities from being exploited, those teams don't need to put so much effort into fixing the bugs during the development process. By getting those out faster, you are increasing your top line, increasing your profit. And also, very, very important, of course, you are stopping breaches from happening. You do not want to be a newspaper headline. So RASP is also then, giving you time to fix your critical vulnerabilities. And fundamentally, it can be deployed anywhere, whether you are on-premise, in the cloud, whether you have a legacy-based architecture, or whether you have a modern microservice-based architecture as well. And because it is at the server-based level, inside essentially your organization, it's also got visibility into east-west traffic that may be happening internal to your organization with that application. So if you have any internal threats, for example, RASP may be able to detect and stop all of those. And finally, I know my colleague Spencer Young was out presented first thing this morning. The RASP solution, as you can see here, fitting in the middle where the application layer is sitting, it is protecting the application layer from causing damage to the data layer. But Imperva has an end-to-end based solution of which RASP is part of that end-to-end protection, protecting all of the paths to your data. And with that, I would like to stop. I'm more than happy and delighted to answer any questions you may have, and it would be great if you would come to our stand 6 and have a talk with the Imperva team. Thank you very much.
Thank you, Simon. Уважаемые участники, если у вас есть вопросы, вы можете их задать. Пока вопросов я не вижу в блоке «Вопросы и ответы» и в чате также. Если они есть, напишите, пожалуйста, не имеет значения, на каком языке, мы переведем, если потребуется. Just a moment, Simon.
No problem.
We are waiting for questions, maybe. No more questions.
Okay.
Thank you so much. Thank you for your speech and for your interesting presentation.
Thank you, and enjoy your evening. Thank you very much.
Thank you. Have a nice evening.
Thank you.